Hi. Hi, everyone. Hi, Petra. Nice to meet you. The first one. Thank you very much for accepting. Yeah. And Philip, thank you very much. Yeah. Arturo, it's nice to meet you as well. Yeah?
Hi, nice to meet you too.
Yes. Well, in 3 minutes we start. Everybody is there, I think. We have a very great audience. Yes, yeah, maybe.
Si gusta probar el audio de todos los participantes,
yes.
Doctor.
Yeah, Philip, can you speak in order to hear you?
Sure. Does this sound all right?
Yeah, it's all right. Yes, Petra is all right. Arturo is all right. Ana Maria, are you here? Yes. Can you prove your microphone, maybe?
Hello, everybody.
Oh, yes, we are here. I will. Okay.
Comenzamos, doctor. Adelante.
Okay. Thank you very much. Okay, when you give me the... Okay.
Correcto, doctor. Comenzamos ya.
Yeah, okay.
Sí.
Okay, good day, everybody. We are now in this round table. It's very, very interesting, this table. As you know, the situation in the world is that the physics is very important for many countries and for the development of the countries and the humanity. And in this occasion, we have very, very nice staff in our round table, and we will speak about the impact of the physics in society. You will see that this is very, very important, and the future of physics. For that, we have four guests, 3 from abroad and 1 from host here from Mexico. And I will not describe the world academical trajectory of each of them because it's too big. I will need too much time, and we don't have so much time. And I prefer that they speak and you ask some questions at the end of the 4 speeches. And but I will introduce you with our guests. The first one is Professor Dr. Petra Rudolph. She is professor in experimental solid-state physics at the University of Groningen in the Netherlands, and she is president of the European Physical Society. We have also Professor Dr. Philip Buxbaum, professor in natural science and photon science at the Stanford University, and director of the Stanford Pulse Institute, president of the American Physical Society. And then we have Dr. Arturo Martí, full professor in nonlinear dynamics and complex systems at the Physics Institute in Montevideo, Uruguay, investigador PDCIVA and SNI, and president of the Ibero-American Physical Society Federation, Federación Iberoamericana de Sociedades de Física, FEIASOFI. And the host from here, from Mexico, is Dr. Ana Maria Cheto. She is professor in quantum and stochastic physics at the Institute of Physics in Mexico, in the Universidad Autónoma de Mexico, with enormous international experience, elected president of the Mexican Physical Society. I think this conference will be very, very excited, and I think it will be very interesting. At the end of the 4 speeches, you will have the audience will have the possibility to ask some questions. We have the very limited time, but some questions will be possible. Then I propose that first we start with Petra Rudolph, the president of the European Physical Society. Please, Petra.
So I'm trying to share.
Yes.
My screen.
Yes, we see your screen.
You can still see it? Yes.
Yes, we see you.
Okay.
We see your
So when you asked me to talk about the importance of physics to society, I thought I would share with you an example of how we talk to politicians. And we talk to politicians with a study that we just did that was presented last year, which shows how physics impacts the economies of Europe. Before I start, just a very short thing about the European Physical Society. So like the Ibero-American Federation, also the European Physical Society is a federation of member societies, 42 to be precise. But we also have individual members, and we have associate members, which would be institutions, universities, companies. So altogether, we represent 130,000 European physicists. And the study I'm going to present you is available on the website of the EPS, the full report and an executive summary. And I will give you even more in a nutshell, the results of this study. It covers 31 countries, the 28 European Union nations, plus Iceland, Norway, and Switzerland over the period 2011-2016. So we all know, all the people who are here around the table and who are listening know that long-term basic research has a big value for our society. But our policymakers, they want evidence of short-term benefit. And that is the difficult thing to demonstrate our regular contribution to society. And what is the most difficult thing to explain is what Charles Townes explains in his book of how the laser happened. What industrialist looking for a new cutting and welding device, or what doctor wanting a new surgical tool would, as the laser turned out to be, would have urged the study of microwave spectroscopy. Of course, that is the connection that people outside physics have such a big difficulty to understand. So we decided to go another way around. We know that physics impacts society in many different fields. And because we do a bad job in explaining this, we decided to do a study which really shows the numbers. So what we did was to study physics-based industries. In a moment, you will see what they are. And what you see is that the turnover of physics-based industries in Europe is 4.4 trillion every year in these 5 years. What are these industries? Well, a big part is specialized manufacturing industries. Another big part is also information and communication, energy production, and then you have smaller ones like professional activities, engineering offices who employ physicists, consultancies, etc. So we go all through publicly available data, which are in the EU base, and we have asked a company to do this study for us. What is very interesting, and this is especially important in these times, is that physics-based industry is much more resilient than other industries in times of crisis. So here you see the example, if you follow the retail in 2013, this is when the economic crisis, which started in 2008, was worst in Europe. You see that there is a big dip in retail. And if you look at the physics-based industries, you can hardly see any difference at all in their turnover. The physics-based industries account for an important amount of the turnover, namely for 16% on average, but it's not distributed uniformly. What I want you to keep in mind is that France, for example, where the physics-based industries only account for 13% of the total turnover in the country, when you look at exports, you see that it's 44% of the EU business economy. So, and here you see the various numbers. Now, Germany is not a surprise. There you say they invest so much, it's good that they get so much back. But you see that even the countries who invest much less, as I just pointed out, for France, 13% is the internal product. When it comes to export, it's nearly 45%. So it's also very important in terms of jobs. So the employment in physics-based industries in Europe reached nearly 18 million in 2016, and that's 1 million more than 5 years earlier. So there is a very big growth of physics-based industries in the economies of Europe. And what is also important is that each job in a physics-based industry creates more than 3 jobs in the total economy. So you have to think of companies that produce for these physics-based industries, and you have to think of the restaurants, the hairdressers, and where all these people spend their money. So that's the impact in the economy. But what is even more interesting is that the physics-based industry is really producing a lot more value than many other types of industries, more than the other types of manufacturing, than construction and retail. So we have to convince our politicians that physics is very important for the economy of our nations, and therefore we need continued support, because all these industries need well-trained people. We have to shift in our mentality. We are not educating people for academia only. Only a small part of our students will end up in academia, and many will end up contributing very positively to the economies of our countries. And for that, also the R&D expenditure must be good enough. In Europe, in 2000, the European governments agreed that they would spend 3% per year on R&D. This target is not met by many of the countries, and that has a big effect on how universities work. Because, for example, in the country where I live, in the Netherlands, in the last 5 years, the amount of students has increased by more than 50%. But the funding to the universities has increased only by 12%. And so what happens now is that how the funding is spent, in 2000, 35% was spent on education and 65% on research. Now it is, now it is opposite. So what you have now is that there is the same amount spent on education and on research. And that is not sustainable for the innovation that we produce on the long term. And that was all I wanted to tell you today about. Thank you very much for your attention.
Oh, thank you very much. It was really very, very interesting. And wow. Okay, then we continue with the other representative of the federations, Latin America, the Ibero-American Federation. I give the word to Arturo Martí. Can you start now?
Yeah, thank you. I'm going to share my screen here.
Yes.
Okay.
Mm-hmm. Okay.
Okay.
Yeah, it's okay.
Good morning, everybody. I am so happy to be here with all of you, and thank you so much to Nacho and the Mexican Society for inviting me. It is a great pleasure to be here with you. I am Arturo Martí. I am the president of the Federación Iberoamericana Sociedad de Física, that is the Ibero-American Federation of Physical Society. This is our website. I invite you to look around it, fediasofi.net. I'm going to briefly introduce the federation. It is a non-profit organization, and the formation was in 2005 in La Plata, Argentina, at the fusion of philosophy and Unisophy. And its membership includes all the countries from the Rio Bravo in Mexico to Tierra del Fuego in Argentina and Chile, and also Spain and Portugal. So the governance of the society is given by an executive committee with 7 members, and we have a general assembly with the president of all the society, and we celebrate the meeting every 2 years. Last meeting was last year in Spain, in Zaragoza. So I'm going I would like to comment about the global pandemic. As you know, Latin America, Spain and Portugal is one of the most affected, or perhaps the most affected region. And we can see here in this map. I expect a huge impact of the pandemic in science, in every field, but particularly in science. There are several impacts. Well, as you know, most of the government around the world have, in particular in our region, have temporarily closed all the educational institutions. Most of the university closed or went online, and in some countries the academic year was partially or totally lost. And I think that the worst is to come yet, because we expect several budget cuts in the following years because of the financial consequences, and we have several groups reoriented the research in this time. But just to be a bit optimist, maybe there are some positive aspects of the pandemic. One is the social recognition of the role of the science to confront the pandemic. The pandemic, the answer to the pandemic is expected to come from the scientists, from the doctor, the physicians, but not only from. We don't expect that the answer comes from the football players, although football players maybe in our society are the most important careers. So we expect that the role of science will be redefined, and we will put this role in an important place. So another aspect is the discussion about the pedagogical method that we use in our university. The pandemic has provoked to redefine and to think again about the pedagogical method that we use, and because most of the course had went online, and we have not direct teaching. So I think that the most important aspect for all the humanity is to think that we are not alone, and we will overcome this pandemic together. And it is not. We are not an island. In every country is not an island, but we are in communication. We are linked to all the other countries. At least it's possible to save alone. So next, I'm going to share a few think about the impact of physics on society, with what the topic of this roundtable. And I think that the physics is every time and everywhere in all the places. So we are going to mention, just to start, an example involving fluid dynamics, solid states of matter, rheology, aerosols, thermodynamics, and several fields of physics and other science. And this is the example. This is the flush toilet. Maybe we are not aware of that every day, but every time we use this device, we are taking profit of more than 2 centuries of development. So I think that there are a lot of impact of physics in all the field. So as it is impossible to discuss about all the impact, I'm going to mention some aspect about the last century. The last century was a lot of advances in physics. For example, I'd like to mention nuclear physics, which result in very strong impact in nuclear weapons, and later on energy and power, and for nuclear power plants, also in medicine. I'd like to mention also the transistor and semiconductor devices, who were discovered about 1947, but the development in electronics were fully exploited several years, several decades after that. We can also mention the laser, with a strong impact in optics and communication, and also the particle physics developed along all the century, but with a huge impact in medical imaging and several other fields. So I think that there are several physics discoveries or advances that until now they don't have yet a fully impact, or they don't have been fully exploited, like superfluidity, high TC superconductivity, quantum computing, cold fusion, etc., gravitational waves, detecting the horizon of the event horizon of the black hole. All there are several discoveries that until now haven't impacted in the society. I'd like to mention also the interaction with biology. Biology was the most, maybe the field of science that have impacted in the last year more deeply. I'd like to mention, for example, the PCR, which has only less than 40 years, but now it is used every day, for example, to detect the coronavirus, the sequencing of the human genome, the genetically modified organisms, the gene editing in several organisms, and also several applications in nanotechnology application. So I think that for the physics, the interaction with biology will have a lot of importance in the next years. So what can we learn about this? I'd like to extract some obvious conclusions about this. The first one is that maybe there are decades decades from the discovery to the technological impact. We have to wait several years to see the consequence of a physical discovery. Obviously, it is difficult or maybe impossible to predict where this impact will appear. Another aspect is the pure theoretical discovery may have huge impact after several years. So there is not a pure science or an applied science. Maybe a pure theoretical issue after a few years will turn out to be very important from a practical point of view. And finally, the physics impacts everywhere, although we are not aware, maybe in some cases, or in most cases, we are not aware of this. And well, this is my email. And bueno, thank you for your attention.
Oh, thank you very much, Arturo. It was very, very interesting. And now I ask Philip to give your speech, please.
Okay, thank you. Thanks very much. I think that I won't share my screen, just to speak to you directly. First of all, saludos de la American Physical Society y feliz 70º aniversario. So you can tell I do not speak Spanish customarily, but I'm very, very happy to be here. And I want to say a few words about this very, very important topic of the future of physics in society. You know, Arturo and also Petra have made the point that physics has held a special place in society. And this has been true for the entire 70 years of the Mexican Physical Society. But that position is now being challenged in today's world, and it's changing fast. And as members of the world physics community, I think we all need to understand this. So I want to speak a little bit about this today. We're all going to make choices in our careers that are going to affect the role of physics in society in this century. You know, the mere fact that this is the topic of this discussion, it reflects already our view that what physicists do affects the world that we live in. So, of course, let's remind ourselves how we got to this favored status, this position of world impact. You know, it's because many things that the communities and nations have needed over the past 70 years have been enabled by advances in physics. Even when technology creates the problem, like pollution, for example, the solutions often rely on advances in science and discoveries and new discoveries in physics. Of course, the primary example that's in everyone's mind is security. Just before the Mexican Physical Society was founded, discoveries in nuclear physics shortened a world war and brought peace. But those same advances led to the scourge of nuclear weapons proliferation and to the very concept of strategic weapons, that is, weapons that are so powerful that they're actually built to deter conflict rather than enable it. Now, as physicists, of course, we shouldn't blame ourselves for the laws of nuclear physics. We have no power over that. But we've also taken a special role in finding ways to use that physics to mitigate the problems that it creates through things like 3D verification science and testing technologies. And you know, this has placed physics on a kind of a pedestal in society. Of course, it's not the only thing that has kept us up there. We've been directly involved in many of the discoveries and advances that have led, for example, to world communication, as Arturo noted, the transistor, the laser, the optical fiber. These were all Nobel Prizes in physics, but more important, inventions that really changed the world. This, of course, is also true in world health. You know, the mere fact that we know it's iconic what the coronavirus looks like. We all know what it looks like, okay? This is because of imaging technology that came directly from fundamental advances in physics, and we all know that. And similarly, the ability to test, to sequence proteins, and even to sequence DNA and know what it looks like, all come from advances in X-ray structure determination in physics and in biophysics of various kinds. You know, energy, of course, nuclear power is a form of energy, but also renewable solar energy, batteries, storage and transmission of energy. Physics is everywhere, and of course, there's much more. You know, wherever we look in the world, wherever we think we cannot quite reach, physics has sought to bring us there. So we have, you know, the Hubble telescope. We have LIGO just in this past decade. We have this marvelous Event Horizon telescope that uses the entire planet as the optical aperture. You know, this is really something, and it's really a number of advances in physics brought this. And what this has done, it's led to a kind of a democracy where every part of the Earth is a place for discovery now. And in Mexico, there's a great example. We have the High Altitude Huachuca Observatory here, which is making fundamental discovery science in astrophysics. And then, of course, you get down to the very small, also the building blocks of life. I talked about X-rays enabling structure determination, but now we even have X-ray lasers that can, you know, even look in places where ordinary X-ray structure hasn't been able to go. So we have a lot to celebrate. We have a lot to be proud of. But I think it's important to remember that this privileged position has come from the respect of the broader community in science and what science can do. And it's created this enduring partnership with government that exists right up until now, based on funding, of course, but also based on freedom and on fairness. Understanding this partnership is really critical for the future. You know, the governments, not just my own government in the United States, but also you know, European national governments and the whole European Union and other national governments, including Mexico, they provide funding and an atmosphere of free exchange of ideas. Then that enables us to advance fundamental science wherever our curiosity leads. And on our side, we also have a part in this bargain because we promise to advance scientific knowledge with fairness and for everyone. And we promise to publish our results throughout the world. And we also promise to train the next generation. Very important. And so for 70 years, this partnership has worked well. So for example, in the United States, as we all know, you know, we have these wonderfully strong labs, and we have universities which are magnets for the best students and researchers from everywhere in the world. That has worked wonderfully until recently. So this is something that we need to understand. Increasing tensions are leading to restrictions that interfere directly with participation in large projects and international conferences and international students who, in the US, international students make up half of our students are international in STEM fields, in physics in particular, our graduate students, and they're increasingly even discouraged from coming. And these tensions, we can measure this. We can see that the applications are beginning to decrease from international students. There's something that's even more troubling than this, although this is really terrible, and that is over the past few years, our own fairness to perform physics in a fair environment has come under question. There have even been arrests of scientists who have been accused of breaches of scientific integrity. That led them to break laws, and so they're arrested for that. But this is sending a really chilling and puzzling message to a lot of scientists. We even have in the US congressional investigations and also our FBI that now claim that international collaborations lead to corruption of science, turning it into espionage. I mean, this is pretty scary stuff. But no matter who is to blame here, whether there are some, scientists or whether it's just government overreach, no matter who is to blame here, that's not my point. My point is this indicates that this fundamental trust between scientists and the community and the government, it's breaking down. And repairing this rift will be one of the most important challenges that physics and the physics community face. And we have to repair it because physics still has a lot to do, as we've heard from the other speaker. Climate change is upon us. In California, where I live, I'm speaking to you today from Menlo Park, California. Just a few weeks ago, the fires were less than 10 kilometers away from here. And fortunately, those are now out, but we've had unprecedented fires, and they're even beginning to threaten water supplies. I know that I read that the Atlantic hurricanes are also increasing in ferocity and frequency. And of course, this is a direct threat to much of Mexico. And sea level rise is happening everywhere, and it's going to cause massive displacements. Biosecurity, of course, I mean, we're having this meeting on Zoom because of issues in biosecurity. And so there are lots of problems that physicists will be key to solve. And then there's also the grand aspirations of future generations. If you want to test cosmology, if you want to discover physics beyond the standard model, all of these things require new solutions that involve new physics applications and things that we haven't even thought about, but we will. So we have to reverse this disturbing trend. How can we do that? Well, this roundtable, this is a really important way. We have to communicate with each other openly to explore the challenges we face, particularly as we pursue physics across national boundaries. And we also have to look inward. We have to rededicate ourselves to the principles of scientific integrity. We have to commit ourselves to objectivity, to honesty, to openness, to fairness, to stewardship, to taking care of the science that we produce. I particularly want to stress the importance of stewardship, because this is what keeps physics working well, that we are faithful to the science that we're working on. The stakes are really high here. We know that continued progress in physics is required to face daunting challenges, and it's only going to become more urgent in the decades to come. There is one, however, very, very good piece of news that I want to leave us all with, and that is that I know this community, and I know that we can meet this challenge. Thanks.
Oh, thank you very much, Philip. This is really very interesting. I think you will have a lot of questions about that in the next. Well, then I give the word to Ana Maria, please.
So, hello, everybody. I'm very pleased to greet here Petra, Philip, and Arturo. And it's a great pleasure for me to have this conversation with you as President-elect of the Mexican Physical Society. Well, as you are well aware by now, the Mexican Physical Society is celebrating its 70th anniversary. This may seem an eternity for the younger ones in the audience, but probably seems a very short time for our colleagues from the European Physical Society and the American Physical Society. Not because you are old, certainly not, but your societies are in comparison or your national member societies in the case of the European Physical Society. If we consider, for example, the Deutsche Physikalische Gesellschaft, which was established in 1899, just the same year as the American Physical Society. The Ibero-American Federation of Physical Societies, by contrast, is only 24 years old, so you are young. Europe has evidently a strong and long-lasting tradition in science and in physics in particular. We are not going to go into the history or our colonial history, etc. But there are, of course, historical reasons for this. The USA entered much more recently, but in full strength. By comparison, one could say that Mexico, as other countries in the region, is in the process of consolidating a tradition. Well, let me refer to the title of our panel. If you ask what has been the impact of physics on society in our country, you probably end up with as many responses as there are respondents. There is not a systematic data gathering and analysis that one can resort to. Not like the study that Petra has mentioned. Ooh, that is a matter of really, well, we would like to have such a thing, no? Therefore, our answers are necessarily partial, even anecdotal, I would say. We physicists share, of course, the conviction that our discipline is essential for society and for our country. You have heard that from our predecessors. But in the other extreme, the layman, the science layman, in particular the businessman and the politician, they may be convinced that we are dispensable. The truth, if such a thing exists, lies somewhere in between. There is barely any local physics-based industry that contributes to our economy. Nor does the local industrial sector create high-skilled jobs for our scientists. And therefore, the country continues to depend heavily on imported technology and on an increasing amount of foreign high-tech industrial goods at a high cost for our economy. In some strategic areas, such as petroleum and its derivatives, there has been a process of deindustrialization in the last 30, 40 years. On the other hand, a few relatively modest physics-based startups have been created in the last decades in areas such as optics and photonics, in material science, computing and information, most of which have a hard time surviving. Individual physicists or industrialists are not to blame, however, for this. This is rather a systemic problem. A decisive state policy that supports innovation and provides incentives to local science-based industry is urgently needed to change this state of affairs. This would have the great advantage of alleviating the technological dependence and contributing to the national economy, while also creating a range of challenging jobs for our young scientists. Well, areas where the impact of physics is perhaps more visible is in education and science popularization. Participation of Mexican students, thanks to the efforts from the Mexican Physical Society in the national, the regional, and the international physics Olympics is a case in point, of which we can be proud, the Mexican Physics Society in particular. Also, you may find here and there some good native physics books, textbooks, very few, and learning materials for different school levels. Yet again, this is mostly due to isolated efforts from individuals or groups rather than to a national policy that takes science education seriously into consideration. In the areas of science popularization, we are better off. Most of the science museums or science centers, as they are called today, offer well-developed physics-related exhibits and workshops, and we witness a flourishing industry of science books, now also blogs and other online publications for children and for the general public, aimed to increase their understanding and appreciation for science. On the other hand, research in physics and physics-related areas such as astronomy, geophysics, meteorology, material science, medical physics, physical engineering, computing, etc., does have a strong presence in the overall research landscape, which is still to a large extent based in universities and other academic institutions, which means that it is strongly linked also to undergraduate and graduate education. Over 15% of the members of the National Research System are in the area of physics and mathematics. Of these 4,708 members, a very small number in itself, unfortunately only 22.6% are women, and as many as 26%, more than a quarter, are concentrated in one institution, the National University of Mexico, of which I am proud to be a member. Research continues to be centralized, despite significant efforts from state universities, such as our host, the Universidad Michoacana. Our research has reasonable presence in the international scene due to some extent to the international collaborations and the areas chosen by our researchers, which are of course very much influenced by the mainstream. We tend to collaborate much more readily with colleagues from the USA and from Europe than with neighbor countries from the South, as Arturo, I am sure, can confirm in our continent. Important efforts have been invested in a few large experimental facilities, notably astronomical observatories and high energy laboratories, as well as in some so-called national laboratories more recently. The research output in the form of papers published in index journals is what is most valued by our academic assessment systems. We also have our own physics journal published by the Mexican Physics Society, which we're proud of since 70 years ago. The journal is also 70 years old. But what is the impact of our research on society? Difficult to tell. The COVID-19 pandemic has brought to light the paramount importance of science-based policy decisions. As elsewhere in our country, a number of research groups and individual scientists, including physicists, are devoting serious efforts to address some of the many challenges posed by this crisis. The present scenario should hopefully serve as an eye-opener for us, for our institutions, and for policymakers on the role science, and in particular physics, can play and is called to play for a healthier development of our society. The Mexican Physical Society and its members share a responsibility in promoting and effecting this change. Of course, we look forward to collaborating with our partner societies in this endeavor. Thank you.
Thank you very much, Ana Maria. It was also very, very interesting. Well, we start now the session of questions. And for the audience, in the bottom of your screen, there is a hand. Then raise your hand, and I will then see that you are asking or asking a question, or want to ask a question. Well, in order, we can wait, there is no questions now, but I have a question before the other people ask something. The question is the following, as is special out. Of course, you have to say to whom is the question, or if you have some more than one questions, then you can say who is the questions asking to, and the question, of course. Well, my question is, there is a real threat against the science. For example, there are now really a very big amount of people saying that the earth is flat, or that the science is spending too much money, and not, or that the scientists are only playing football or something like that. For example, in this series of Big Bang Theory, it seems of whether that we are only playing games in the computer or something like that, but it is not true. In my question is, what can we do against that? Because when that is only in the society, maybe people that is not very high qualified, this is not so important. But when that is in the politicians, and this current of people is also in the politician, then this is very dangerous. What do you mean? What can we do? Maybe Petra and the rest can also make some remark about that. But yeah, I am really very concerned about that. Please. To Philip.
To start?
Yes.
I think, well, I'm happy to jump in and answer this, because this, of course, this is one of the important functions of outreach. I mean, there's a two-sided coin to having physics be influential, and that is that it has to be also broadly recognized as part of society. That is, when if we put ourselves or others put us on a high pedestal so that we seem sort of rarefied and unique, that's actually not a very good thing, because first of all, it's not true, but also because it makes it possible for people to not appreciate how important the fact that we're embedded in the world is. I mean, we choose the problems that we work on based on who we are, where we live, what we see. And I think there's a tremendous partnership that's actually there that needs to be exploited and talked about.
Yeah, I think that we all have to make an effort to explain when we go to a party, when we meet family and so on, what we are doing. And so when people ask me, what are you doing? My standard answer is, I invent the materials that will be in your mobile phone in 5 or 10 years from now. And then people think that they can relate to it. It's not a lie. It's true that what we are working on are materials which are probably going to be in the mobile phones or in other things. But you have to make people, you have to be ready to explain that what we are doing will have an impact. And you have to explain it with words that people can relate to. And so that's something we have to train our students in, and we have to train ourselves in to do that better. And I think this is the best. If we all talk about what we are doing constantly, the word will spread.
Mm-hmm. Okay.
It's also important to talk to the politicians. I mean, this is something that you brought up, that when the politicians are beginning to doubt science. Why? Because they don't know any scientists. They don't talk to scientists. They don't have scientists who they feel are part of their team. It's really important that when you have the opportunity, that you take it to speak to the leaders.
Mm-hmm. Yes. Okay. Thank you very much. Arturo, do you have a question?
Well, no, I like to comment about a question from the audience.
Okay.
The question is, which is the best way to model the pandemics? Well, I don't know which is the best way to model the pandemic, but I like to comment two kind of recommendation. The first one is to confront with real experimental data. And the second one is to work together and in close contact with epidemiologists and statisticians. There is a big field of knowledge from epidemiology from maybe 100 years, and it is not good for the physicists to try to rediscover what all the epidemiologists know from many times. So my two recommendations are this: to work together with epidemiologists and to confront with real data.
Okay, thank you very much. There is a question from Lamberto Castro. Do you want to ask? Lamberto Castro is in the attendees.
No, it was the question that I commented before.
Ah, okay. Lorena Romero.
Tonatiuh?
Yeah, okay.
Yes, because I would, yes, may I talk now?
Yes, of course. Ana Maria.
Yes, because, sorry, but I wanted to go back to your question. What can we do to change the politicians' view about us, about physics?
Yes, okay.
And well, we have heard Petra and we have heard Philip. I think what they have said is very important, but I would like to add in something. Namely, I think we have to work more closely together with the educational system, because at least in our country, but I think this is not just our problem, we have a serious problem with science education in elementary schools and in high schools. And if the view and the understanding of science and a bit of knowledge and rational thinking, which is something that science education gives us, is not introduced in our system, because it's not today, then it will be difficult to change the views of the public and politicians in particular on science. Now, there's also another thing that can help. This is bottom up in a way, no? But something that can also help is to have respectable, high-level politicians who are scientists, who are physicists. For the first time in Mexico, we have a governor, the governor of Mexico, of the city of Mexico, in fact. She's not only a physicist, but she is a woman. Well, she made her PhD in engineering, but she is a physicist. And you can see a change. The way she has managed the pandemic, but not only that, the way she has also introduced science, a system for science-based decisions. I think she is making a difference. So that is also important, to have high-level politicians who not only have a broad understanding of science, but who are scientists themselves. Not that scientists will save the world, but we have a role to play. Thank you.
And thank you very much. There is another question, Lorena Romero. Do you want to ask that yourself, or do you prefer that I read your question? Lorena Romero?
Okay, I can ask.
Okay.
I was wondering, hello everybody. I was wondering about how are you approaching to politics and politicians about their acknowledgement that our current situation is going to diminish our products in theoretical physics or in experimental physics, because we have limited access, I mean, to the laboratories, or because the projects are not being funded in the same way, I mean, because of the processes that we have here in the, well, at least at our current situation. I mean, we're still in the, what we call an orange light here and at Toluca where I'm at, but I think that this should be addressed, because we are evaluated every day and for every year because of our products. So that's my question. Thank you very much.
Can I answer? I can
Petra,
just,
yeah, please.
how we are handling that in Europe. Right now, there are many actions going on by young scientists, and the learned societies, of course, support them as much as we can, to make it clear to the European Parliament, for example, that has to decide on the EU funding for research, or to the individual governments, that what we need is a massive investment in science, especially for young scientists in the coming years, because it is science that will save the economy. What we are doing and what we are producing is is of the highest innovative content, and the young scientists are the ones who have suffered most from the pandemic. So if we want to have a sustainable development over the next 20 years, they have to be massively supported. And I can tell you that if you go and talk to parliamentarians individually and you make them aware of the stories that you live, they listen. So I strongly encourage you really to devote some time to that and to make them participate in your life, because they will react. At least that's what we see here, and I don't see why in Mexico it should be any different.
Yeah, I think so. Yes. Any other remark?
I can only reinforce what Petra is saying. In the United States, I think the situation is similar. There are very strong efforts to make sure that these very large COVID relief packages are not just considered as bandages, which of course are very important to have bandages for first aid. But in addition to that, you have to solve the underlying systemic problems, and there are efforts underway to do that. Of course, a lot of political turmoil on the surface right now, but underneath, I think there's a strong move in that direction, and I hope to see that in the next coming years once we come out of this pandemic.
Okay, thank you very much. Okay, there is another question. Luis Ureña, you want to ask that directly? Luis Ureña.
Yes, thank you very much, Donatu. I want to thank all the panelists for very nice, these very nice opinions about physics and science in general. My question is, can you please share your thoughts about improving the science curriculum in elementary schools? I think that this may help society to believe and understand better science in general, and in particular physics. Thanks.
Petra?
So the best example that I have from Europe is the United Kingdom, because there is a very large foundation which has hired physicists to go and into physicists and biologists and chemists, but it's mainly physicists who are doing it right now, who are going into elementary schools. So one teacher is responsible for one school, or if the school is too big, 2 teachers, and they come once per week into the elementary class, and they just do experiments with the children. No explanation, just having fun with doing experiments and observing. And these kids are wonderful. I was visiting, and they can explain to you what the scientific method is much better than many of my freshmen in physics can do, just because they have been stimulated to think in a scientific way. And I think that's very important, that we go away from explaining things and we bring children to discover things. And if we can do that, we have new generations that are very, very powerful.
Mm-hmm. Arturo, you wanted to say something?
Petra explained better than me. I want to stress that children can do research in their way, can investigate, and the best way is to promote curiosity and promote that children discover by themselves. I think that an active attitude is the best recipe.
Okay, thank you very much.
A very short comment. We have a lot of elementary school teachers who are scared of science because they don't have a science background. And so they are scared to talk about it. And this is why this solution to have special people who come in is a good solution, because then the main teacher of the class does not have to be scared.
Thank you very much. Enrique Guzman asked about the possibility to have your presentation, Petra. Is it possible to get it? Yeah, okay. Then is there some link? I will share this link before later, okay? Okay. Edgar Calleros want to ask something? Edgar Calleros?
Yes.
Okay, may ask your question.
Yeah, hello. My question is, how do we justify to the general public and to politicians research in fundamental science? For example, physicists doing research and looking for evidence or models beyond the standard model, which do not have a direct application in the near future.
Well, this is, of course, a recurring question, and something that I always counter with is that there's no, one doesn't seem to have such difficulty in selling, the Hubble telescope images, for example. They grace the screensavers on many people's computer screens, and why is that? Well, you could just say, well, it's because telescope images are beautiful, and of course that's true. But really, what it is a very strong effort by the astrophysics community to make sure that every step of the way they involve communication with the general public at all levels and in all ways that they can think of, including the screensavers. And this convinces me that fundamental physics, of course, we all think, those of us who do fundamental physics of any kind think that it's beautiful and fascinating and engaging, but that's not an elite view. That's a view that can definitely be shared by anyone else in the community if we put effort into explaining why we find that it's beautiful. So I understand it's a very general answer rather than a specific go do this, but I think it's an important thing to keep in mind.
Yeah, thank you very much. Is there another remark about that? Miguel Lindero has a remark.
Sorry.
Sorry, okay. Ana Maria, please.
Yes, I would like to also contribute to this
okay.
With an answer to this question. It is a recurring question indeed. Philip knows it very well. Also for us. And I'd like to talk about an experience that for me was very enlightening when we were promoting the International Year of Light with your predecessor, Petra, with John Dudley. We went to New York to convince the representatives of member states to the United Nations that light and light-related technologies are very important, as Philip knows well, no? And so, well, I'm a theoretical physicist. For me, light is very important. It's part of my job. And it is important for each one of us as physicists, but that is not what is interesting for politicians or for diplomats. So a member of our team, of the steering committee of the International Year of Light, was the president of the of the Optical Society, OSA, the Optical Society of America. And he brought with him a kit, a tool kit, with all kinds of small light-related things, lasers and mirrors and I don't know what. And he gave some figures, very impressive figures, like the ones you read out, Petra, in your intervention, on how the light and photonics and light-related technologies contribute to the economy of the most developed countries. I don't know if his figures were exaggerated, but he mentioned something like 30%. And that is what convinced the United Nations Assembly, in fact, we got the International Year approved by consensus. For the first time, an International Year didn't have to be subject to a voting. But he also mentioned, we all mentioned how the fundamental physics is behind all those technologies. And as Philip said it very clearly, science-based technology nowadays is very much science-based. And when people realize that we would not be here talking to each other if it were not for fundamental physics, then I think that helps, no? Or it should help. We have to spread the word more clearly, perhaps.
Thank you very much, Ana Maria. We have a remark from Miguel Lindero. Do you want to make your remark for all the public, or Miguel Lindero? Oh, no, it's not answered. Well, we have another question from Maria Sergeva. Are you here? Maria Sergeva? Do you want to make ask your question alive?
Yes.
She is not here. Yes, okay. Well, then I think we are over. There is another question?
There are some written questions. Which
okay, I read the question from Maria Sergeva. Please
there is one.
Okay, I read it. She prefers as I read. Okay, speaking on the future of physics, I see that following tendency. Previously, people knew more about physics laws and how the things work because they closed them very often in their everyday life. Nowadays, a lot of technology replaces thinking and acting. This results in that the people lose their knowledge without practice. It seems that some of the physics knowledge will be only for scientists. What can we do with that? A rhetoric question? Okay, do you want to?
I fully agree with Maria Sergeva.
Okay.
I think that today, especially for a student, it's very easy to get the information, but it's not so easy to experiment and to experiment with the real world. But on the contrary, they have a lot of information available. So I think that the best way to proceed is to in the educational institution not to put emphasis in the information, but to stress on the experimental activities and experimental fact by the student themselves.
Is there another remark about that?
I do have a kind of remark on that, because I think that we're sometimes missing opportunities that technology provide us to bring experiments in physics back in. And I'll just give you one very simple example. Almost every student that I teach has a smartphone now, almost everyone. And they look at these smartphones as ways of staying connected with their friends, and that's why they have them. But actually, everyone is an extremely sensitive physics instrument. And there are apps out there that can take advantage of that can allow you to use your the thing is, it's got gravitational sensors in it, it's got accelerometers, it's got light sensors, it's got a fabulous camera which actually can be used as a spectrometer as well if the app takes advantage of the color, and it's quite a good spectrometer, and we need to take advantage of this and make it so that the things that students really love to spend all of their time with, they begin looking at as tools for exploration and discovery and experimentation, and not just watching movies and things on Facebook.
Okay, thank you very much. There is another question. Catherine Paola has a question.
Yeah, thank you. My question is, how can we encourage students to not only learn to do science, but also to share that knowledge with their classmates, with their family and other people? Thank you.
Who is able to answer?
I can tell you what we are doing with the European Physical Society. We have Young Minds sections, which are groups of students, PhD students and postdocs that are helped always by one faculty member of the physics department. And the European Physical Society gives them training in leadership and makes them meet physically online and so on. But we ask something in return. We ask that they do outreach, and we also train them to do outreach. So in this way, kids are much more easily influenced by somebody who is nearly the same age than they are by me. So students are much more effective ambassadors than I am. And that has to be encouraged. So that's how we do. And I think you can probably do the same. It's not so complicated to organize if you don't have it yet. So.
Thank you very much. There is another question. Aldo Pasos.
Hello, can you hear me?
Yes, we can hear you.
So first of all, I want to ask this question as a student. I'm a graduate student here in Mexico. That's important for the question. So as all of you know, and as all of the other students know, the current scheme for growing as from a student to a researcher in a field, even for going to academia or a private industry, is to try to build as many publications as you can, to do as much research as you can, and try to make that research have an impact in the community in a certain way that it's reflected on publications, right? We know that the number of publications made worldwide in the physical community is very large. There's a large amount of information. We can arguably speak about, for example, Physical Review Letters, a journal that is published 57 times a year. We can open the weekly version of the journal, and we're going to find a lot of interesting, high-impact research that may be related to some field that we know, whatever. But the thing is that a lot of research publications are generated. Many of them have not the impact that we expect, which is understandable because that's the way science grows. We do not expect that all the research that is published or made can be useful or can have an impact. We know that's a fact, and that's something that it's expected. However, my question goes, even if we expect that, does the number of publications that actually goes on without having a usual effect on society or a deep effect on the physical community, isn't it too large? And also, does the current evaluation scheme for researchers and for students of having as much publications as you can to reflect your value as a researcher doesn't also makes the fact that there's a lot of research that doesn't have a general impact, much more than what is expected. And if you agree with the fact that that might be a factor in having many publications and a lot of research that doesn't have an impact, if you think that's a problem, and if so, how would you address it, or how is it being addressed? Thank you.
Well, I think there are a lot of points that you raised that are certainly under intense discussion in the physical societies, particularly the ones that that are devoted to publishing archival stuff in physics. Publishing is going to be changing. I mean, one of my own personal answers to a question like that is to point out that the I think it's no, I don't want to say the wrong one. I think it's the Einstein-Podolsky-Rosen paper, which was published in the Physical Review in the 1930s, had almost no citations for decades. And then since the 1990s, of course, it's one of the most highly cited papers in quantum information. So never underestimate these so-called low impact papers. You know, there's stuff there. So that's, of course, that's one answer. But another one, though, is the opportunity to search efficiently, which, of course, also comes from in many aspects of physics research and on big data has helped with that. But the opportunity to search broadly and specifically has actually created much more of a democratization or a leveling of the playing field of the different journals. Now, it is true that the high impact journals are still the high impact journals, and the impact factors don't change very much over time. But what you are seeing is that a paper that's of value published in a solid archival journal that's not considered one of the high impact journals is just as easy for another researcher to discover through search if they're trying to solve a problem than anything that's in one of the highest impact journals. And I'm saying this as president of a society that publishes one of the a set of high impact journals. So I'm not, you know, I'm not trying to undersell our own product, not at all. I'm simply pointing out that this explosion in publication is not something that is overwhelming the value of individual publications. It's still very important. I believe that publishing will change simply because the economics of publishing has to change. But something that will not change, at least not soon, I don't think, is the need to publish. As I always tell my own students working in the lab, you know, why do we keep these notebooks and publish these papers? It's just it's as if it didn't happen if you don't let other people know. And if it didn't happen, then somebody else will have to come along later and discover it again. And you're simply, you know, you don't want to hold back the progress of science in that way. It's very, very important to publish in a way that it can be reviewed, can be criticized, and eventually enter the archive.
Yeah, thank you very much. Petra, do you want to say something?
Maybe one of the things that you said, that it is the number of publications that you are valued by, that is something which is no longer that much true in Europe, at least. We are moving away from just bean counting, and we are much more looking at what is the impact that you have made with your research. And that, curiously enough, is something that helps female researchers, because there are lots of statistics that female researchers publish less because they publish more comprehensive papers. So they are not happy with just publishing one finding. And I was very surprised when I discovered that, because this is the complaint that when I still had bosses that could tell me something, they were always pushing me to publish. And I was saying, no, I don't understand everything yet, and so I'm not publishing yet. And that was a constant source of conflict. It seems that many women think in the way that I have always thought, and then their papers are cited more. And the difference is statistically relevant. So you should think of making papers that really give an answer by collecting, not salami publishing, but by collecting things to really understand something. And you will see that that will be much more appreciated by the community.
Thank you very much. There is time for only the last question. Arturo Robledo Martinez want to ask something. This is the last question. Okay, Arturo Robledo.
Okay, hello. I'm sorry to introduce a digression. I have a very specific question for Philip. You mentioned that students in their mobile phones have a powerful spectrometer. Where can I find information about that? I would like to implement that for a lab, for my lab course. Thank you.
Okay, I can give you some. Of course, I don't have the opportunity at the last minute to give you specifics on this, but I will give you one specific that I think will help you, and that is if you look at the apps that have been produced and are available for smartphones, you'll find that there are physics toolboxes of various kinds. I'm not trying to promote a particular one because there's more than one. And some of these do most of them actually do spectroscopic tasks. So I would certainly start by looking there.
Okay, thank you very much. We have, the time is over.
Ana Maria has an example, so.
Here it is. And it's free. You can download it anytime.
What's the name?
Spectra Snap.
Okay, thank you.
Yes, and there are others, yes. Since I have the microphone, I would like to add a word on this issue of evaluation of performance of researchers and the number of publications. I think we are going through interesting times. I think awareness is increasing that this has to change, that not only for the benefit of females, but more generally also for the benefit of science, I would say, in general. And some signs of this change are, for example, the San Francisco Declaration, DORA, D-O-R-A, where Bruce Alberts, former president of the National Science Foundation for Science, was one of the leading authors. The current evaluation system is also, there is evidence now that it is leading to not good practices in science publishing, in fact, to even malicious, fraudulent practices. And this is also already some cause for concern in the academic environment. So I think it is time to think more seriously on how to promote this change in our evaluation systems. I was happy to hear what Petra said, and I think we can join forces in this regard, because it's not doing any good to science. This just publish or perish and just look at the numbers and look at the citations of the last 2 years. The EPR paper of 1935 is an excellent example of that. And there are many others. If you want to do fundamental physics that is serious, it may take some years until the rest of the community realizes what it means. No? So it's good to have made this point. I'm happy that Aldo Pasos raised this question. Thank you.
Thank you very much.
I'd like to invite you to visit this website that is our group, and there are a lot of information about several, for example, spectrometer, I don't know, many experiments using a smartphone. I invite all of you to visit this website. Thank you.
Okay, thank you very much. Our time is over. Thank you very much for all of them, or all of you, and all the audience. Was really very, very interesting, amazing. And maybe we meet again, but now in Mexico the next time, and we can talk about that a little longer and a little more closer. Thank you very much again. And where we have now a new another talk about dark matter and something like that. Carlos Frank from Durham in England, and maybe you can stay here, but we have to give the webinar to the other conference. Thank you very much again. Bye.
Thank you, and happy birthday.
Thank you, thank you, thank you.
Thank you to all of you.
Yeah, thank you.
Thank you.